Okay, so representing patterns on a graph is relatively straightforward. You need grid paper, it doesn't hurt to have a calculator, and let's review quickly Caleb's problem that we were examining earlier today. Caleb is playing a video game called Real Life. His current job, he earns 2 tokens for each task that he does. One piece of clothing costs 16 tokens, and Caleb wants to buy clothing. He knows the clothing costs 16 tokens, so basically what he's doing is he needs to know how many tasks he has to complete, or n, in order to earn 16 tokens. In his solution, he describes that he's using the pattern rule n times 2. How did he find multiplied by 2? Well, he examined the common difference in his term values for the total tokens earned. And the common difference is plus 2 each time. Whenever you have a constant common difference like that, you can multiply the common difference by the number of tasks, or by the term number. Then what he's done is he's taken the data from his term number and the data from his term value and combined them into coordinate pairs. So 0, 0 represents the first coordinate pair that he could use on his graph. 1, 2 represents the next coordinate pair, and then so on, all the way up to 4, 8. Whenever you create a coordinate pair, the first digit, so if I write the coordinate pair 4, 8, which is the last number in the series for his term number and for his term value. By writing this down, this is what it means. The 4 represents the digit in the x-axis, so that represents x. And the 8 represents the digit in the y-axis, so that's y. So again, in this case, the term numbers represent the digits walking along the x-axis, and the x-axis is here. It runs horizontally. And the y-axis runs vertically, so up and down. Okay, let's move on and have a look at our graph. So what Caleb has done, he's plotted the points from the table of values, 0, 0, 1, 2, 2, 4, 3, 6, 4, 8. And he's plotted them here, 0, 0, 1, 2, 2, 4, 3 across the x-axis, 6 up, 4 across the x-axis, 8 up. And again, he's chosen to use the common difference found in his table of values related to his term values in this column right here. There's an increase of 2 each time, and he's used that when creating his y-axis, because the y-axis represents the term value as well. So he counted by 2, using the common difference as a helper. By doing this, each term value is on a line on the grid. The more precise the grid, the easier it is to use your grid to extrapolate information. That means to collect information related to your pattern, but not shown. So I have to fix my line. The line's a little bit off. I'm going to change the format so it's a solid line. Maybe a little bit bigger too. Okay. So I'm going to take the current line and extend it, including the original point, going all the way up. And what does this show you? Well, this shows you that the same line, the same pattern, can continue on forever. But we can also gather some more important information from this. And the important information is that if I want to find out how many tasks I have to do to complete 16 or to receive 16 tokens, 16 tokens is right here. And if I go all the way to the line that represents the relationship between the number of tasks completed and the number of tokens earned, when I go straight down, I can use the graph line to find out the answer to my problem, the number of tasks required. And I think Caleb also explained some of this information over here about how he's doing his graphing. To plot the points for 4 tasks and 8 tokens, Caleb started at 0 on the x-axis and moved 4 to the right. So he's plotting the point 4, 8 right here. So he moved 4 spaces to the right, and then he moved 8 up. And that created the point 4, 8 on his graph line. So what would this point up here be called? What's the coordinate pair for it? Take your best guess. The x-axis, walk along it until you get to the blue line. Yep. And then the y-axis, go up. You got it. So that's the coordinate pair. And what does this mean in real life? This means that when Caleb plays the real life game, Caleb needs to complete 8 tasks to receive 16 tokens. That's what the coordinate pair tells you. And that's what the graph tells you too. By completing 8 tasks, Caleb gets 16 tokens. So if Caleb was to complete 12 tasks, how many tokens would he get? Simply extend your graph line and make your graph bigger. You can use the same pattern to predict any number of combinations of points that match up with this line.